to actually compute the area. So we have a parallelogram, okay? And I think most people would say that because if we have something like a square, or a rectangle, let's say, normally the longer side is called the length, and the shorter side is called the width. So this is actually also a parallelogram. So is a square, where in this case the length and the width is the same. So we have, in this case, the area will be length times width. In this case, the area is side to the fourth, or side squared, sorry. And in both cases, we end up with square units. All right? So most kids, I think, are going to go with this, and that's how they're going to be led astray, because some of you are going to be able to figure out that if we go 3 units over, if we use the original line, that's 3, and we go down 1, 2, 3, 4, that's 4. Then the hypotenuse here is going to be 5, because that's a 3, 4, 5 right triangle, right? This would be a right angle here. By the way, you could have done it by dropping down over here as well. Right? That's still going to be 4, and that's still going to be 3 there. You could also have done the Pythagorean theorem and got 3 squared plus 4 squared equals, c squared. And this would have been 9 plus 16 equals c squared. And then you got 25 equals c squared. And then 5 equals c. Okay? So you have a couple ways to do this. The best is just knowing this is a 3, 4, 5. And it told us it was 1 unit away, so we know the length of this is 1. So I think enough of you are going to use this here, the length times the width, and just do 5 times 1 and get 5, which would be c. Okay, that doesn't work because of the little slanting issue here. Because if we do that, we get a little triangle at the end of here. And if we do that, we get a little triangle at the end of here. And then the question is, how long is it from here to here? Up until then, because it doesn't actually meet it. So we know it's less than 5 then. Right? And the question is, if I take this and tack it on to the end of that, how much longer does it end up being? Is it 4? Is it 3 point something? Is it 4 point something? Is it like 4.9? Is it 4.1? Is it 3.9? We don't quite know. There is a way to calculate it, because if that's 1, we can actually get information about that. But it gets super ugly super fast. And we didn't even want to do this calculation, okay? Because you should have already known about 3, 4, 5 right triangles. All right? So what is the area of a parallelogram? So what I'm going to do is bring up another slide here. So we're going to talk about what's the area of a parallelogram. I'm trying to see if all this fits on here and is legible. Just make sure it gets in focus. Okay, yes, it seems to be. So here's the example I gave before. We have length times width. And it works for a rectangle, and it works for a square. But when you have something like this, where there's a slant, so to speak, it's not working the same way. And it's not working the same way because of the same reason of these 2 triangles. Now the right triangle on the right, if we were to take the area of that, they're only showing the right triangle to show that c squared equals a squared plus b squared. But on that right triangle, we know that the area of triangles 1/2 BH, it turns out that the A and B on a triangle like this is the height. And this would be the base here, and this would be the height. Okay, that wasn't why they gave it on here, but it would just work out that way. All right? Just got important text. So if you notice, to get the area of any triangle, not just a right triangle, they have the area equals 1/2 BH here. And it's the height here. That's the height there, stuck in the middle of it. So it just so happens if we take that triangle and kind of twist this way to make it here, That's how we get why it's 1/2 BH on a right triangle, by doing that. All right? So this was the original triangle here. If we kind of move this over and twisted it so it becomes like that, that's why this becomes the B and this is the H. So why am I talking about this? Because this is the same problem. And it turns out the height of this parallelogram is not right here. The height of this parallelogram is this right there. All right? So that's significant and important. Okay, so if we bring the original problem back, our height is 4. That's our height right there. Our y is going from 5'1" to, what was the original one? 2'5". So we have 2'5", we have y2 minus y1. We have 5 minus 1 is 4. So we have two ways to do this. We can do it visually, or we can use the coordinates to detect it. We could also resolve the 3 the same way, because we have 2 minus 5 gives minus 3. And the line was originally this way, which is a negative slope. So that works. All right? But we still know it's 3 units over. In this case, it would have been 3 units like that, going like this. Okay, so essentially we get a square here to do that triangle. All right? We're not looking for the area of the triangle. We're looking for the area inside of here, though. So anyway, our height is 4, and our base is the little 1 square here. Okay? So the area of parallelogram is not just length times width, it's base times height. So our base is 1 and our height is 4. So we get 4 square units. So that's how that one worked. All right? So the answer for B, so we kind of guessed by kind of counting the fill-ins in the very beginning, but then we methodically went through and we've proved it mathematically now that that's how it works, and the answer would be 3 would be B then. Okay?